Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi taala wabarakatuh. To Madam Kamila or me. So we would like to present about the network design problem-based task. So this is our group members. Me, Isikuan Nabil Nizam, Muhammad Amirul, and I'm Muhammad Khan. So this is the current network environment. This is the question lah. Okay, so we moving to test one. Refer to the floor plan provided and current network environment, perform requirement analysis and requirement selection. So we need to identify the suitable network equipment and connectivity for each network layer and for each department's rooms and users. So answer for test one. Requirement analysis, separate the departments, IT, R&D, and finance need their own secure network segments. Number two, control wireless access. Staff and guests need separate Wi-Fi. Guests should only get internet. Number three, share the printer. Everyone should be able to use the network printer, but departments should still be isolated from each other. Make it scalable. Use a structure design, core, distribution, access, so the network is easy to manage and expand in the future. This is the equipment selection. Network layer function. So the core and distribution layer, access layer, wireless, internet, router, cabling, and cabling between switches. Okay. Equipment mode, Cisco 35960 switch, Cisco 2960 switch for access layer, WRT300N for wireless, Cisco 2911 router for internet router, category 6 UTP cable for cabling device to switch, OM3 multi-mode fiber for cabling between switches. So the quantity is 1, 2, 4, 1, 4, 2 pairs. So why we choose it? Why we choose the core and distribution layer is powerful switch to route traffic between VLANs and act as the network backbone. So why we choose the access layer is standard switches to connect computers and printer in each department. For wireless, this is because to be used as standalone access points, some for staff Wi-Fi, other for guest Wi-Fi. For the internet router, this is because a common and capable router in packet tracer to connect to the internet and provide DHCP services. For the cabling device to switch, is because for gigabit speed connections to all device. For the cabling between switches, okay. So for cabling between switches is about for high speed backbone links between switches. So we're moving to task 2. Build physical topology design using floor plan provided design LAN cabling, plans by showing connection for each device, create horizontal cabling layout for departmental rooms, create vertical layout from MDF room to floor distribution switches, indicate wireless AP placement for guest and staff Wi-Fi coverage. Okay, so this is the answer task 2. The physical topology shows the MDF, a room hosting a Cisco 3560 core switch and Cisco 2911 router as the main backbone. So this is the rack. This one, 1, 2, 3, 4, 4. So we're moving to explanation. Okay, this rack is connected to wait. Okay, the IDF are placed at the left center and right areas to connect all departments using OM3 fiber. The red cable. Okay. For backbone links and Cat6 UTP for horizontal cabling. For WRT 3009 access point provide complete wireless coverage for both staff VLAN 20 and guest VLAN 99 networks. The design ensure full LAN and Wi-Fi connectivity with efficient cabling distribution. The green eclipse symbolizes the coverage area of Wi-Fi from access point AP. So okay, so let me explain in Malay language lah. Ni, so apa yang you nampak kat sini, ini adalah rack. So rack ni adalah rack apa tu? Apa nampak? Okay. So this rack is dekat dengan reception. So dia connect to printing room, finance and access point. Okay, so the middle rack is connected to access point, presentation room, the discussion room, and the meeting room. So the third, it's not the third lah. The rack yang dekat dengan apa ni? Okay, so dekat dengan R&D ni, they connect to R&D. Okay, they connect to R&D, they connect to IT and IT manager room. So the rack yang kat atas ni dia adalah macam the main rack. So dia connect to semua rack yang lain pakai kabel merah tu. So takat tu saja untuk presentation saya. Terima kasih.
Okay, so we are going to move on to task 3. That is build logical network design and configuration using Packet Tracer. Design and construct logical network topology of the organization using Cisco Packet Tracer based on the given floor plan. This design should include plan segmentation, IP addressing scheme, inter-VLAN routing, and access control rules that ensures each department is isolated and cannot communicate with others. All departments can access the shared network printer. Wireless access for guests and staff use separate SSIDs, and VLAN can access to internet. So as one can see in front here is our topology based on the floor plan that is been given previously. And then for the task 3, so what we're going to do is for wireless stuff, we are going to go into the wireless and we are going to go to the internet. First, we're going to go into wireless and we are going to disable. And also next, we are going to go into the reception Wi-Fi to the internet. And we are going to stack the IP as static and we are going to set the IP address is 192.168.20.2. Subnet mask 255.255.255.0 and the default gateway is 192.168.20.1. And for wireless guests, for central in the same also central Wi-Fi, we're going to go to the wireless and we're going to disable for the authentication. And then for the internet, what we're going to do is we're going to put the IP configuration as static. So the IP address will be 192.168.99.2. The subnet mask will be 255.255.255.0. And the default gateway will be 192.168.99.1. Okay, so we're moving on to task 4. Build network type and testing using Packet Tracer. Use your logical network design from task 3 to develop a functional network prototype in Cisco Packet Tracer. The prototype should demonstrate correct configuration and connectivity testing, verify VLAN communication restriction, verify inter-VLAN communication restriction, test share printer access from all departments, test guest and staff wireless access, capture ping results for verification. So for the answer for task 4, verify VLAN communication restriction. So what we're going to do is ping between PC in the same LAN. So what you can see is over here, ping 192.168.10.11. As you can see, we have the result. We can get the reply and it's ping and it's 0% loss. And then we're going to find the verify inter-VLAN communication restriction. Different VLANs are isolated. Finance to IT, it should fail. So when we try to ping, it must be failed because it's in the different VLANs are isolated. And then for test share printer access from all departments. So for finance, what we can see is from finance, if we ping 192.168.50.2, we can see the output as we get is getting reply and is 0% loss. And then from reception, if you ping 192.168.50.2, it's going to be the same. Also, we're getting reply and the output is 0% loss. Next is from test share printer access from all departments from presentation. We are going to ping 192.168.50.2. It's going to be the same. We are getting reply and the output is 0% loss. And from IT department, the same thing we're going to do 192.168.50.2. We will get the reply and we will get 0% loss. And then for test share printer access from all departments, R&D department, we are going to do the same thing also. We're going to ping 192.168.50.2. We will get the reply and also the output as 0% loss. Next for test guest and staff wireless access. So for guest, the internet IP address 192.168.99.2, as I said just now. So what we're going to do is we're going to ping 192.168.92.2 and we'll get the output and also we'll get the reply. Test get and staff wireless access. So we're going to do from staff. The staff IP is 192.168.20.2 and then we're going to ping and we'll get the reply and also as 0% loss. So that's all for me. Moving on to task number.
Assalamualaikum. So I'll be presenting task 5. So task 5 is executive summary provide a concise overview of the project objective. Next. Executive summary provide a concise overview of the project objective, design scope, and expected outcome of the proposed network. So this project design a secure and efficient local area network LAN for a multi-department organization using Cisco Packet Tracer. The network includes structured cabling, VLAN segmentation, inter-VLAN routing, and separate SSIDs for staff and guest wireless access. A core switch and a router manage routing, DHCP, and internet connectivity, while access switches connect departmental devices and printers. The final network ensures isolated communication between departments, shared printers access, reliable wireless coverage, and scalability for future expansion. So for P is the network requirement. Describe the organization requirement and objective, include user requirements, scalability needs, and wireless access expectation. Identify the suitable network equipment and facility for each network layer and for each department's rooms and user. The organization requires a secure and scalable LAN to connect multiple departments such as finance, IT, R&D, meeting, and reception. Each department operates in a separate VLAN for security, while all share a common printer and internet access. The network must also provide wireless access for both staff and guests to separate SSIDs. The design follows a 3-layer module, which is core, access, and wireless. So for core layer is Cisco 3560 for inter-VLAN routing and backbone connection. Access layer, Cisco 2960 switches for PCs, printers, and access points. And wireless layer, the WRT300N access point for staff VLAN 20 and guest VLAN 99. So for C, current network environment, briefly explain the current problems that justify the new network design. So the existing network lacks proper segmentation and structured cabling, causing frequent congestion and security risks between departments. All users share a single broadcast domain, leading to slow performance and limited control over data access. There is no centralized management for printers or wireless connection, and the current Wi-Fi setup does not separate guest and the staff access. Additionally, the network has a poor scalability and cannot support feature growth or additional devices efficiently. These issues justify the implementation of a new structured and VLAN-based network design to improve performance, security, and manageability. So, the proposed physical design present your physical topology, show cabling layout, equipment placement, and network hierarchy, include diagrams of horizontal and vertical layouts. So, the proposed physical design is based on a structured cabling using three-layer hierarchy model consisting of the core, distribution, and access. The core layer is located in the main distribution frame MDF room, hosting the Cisco 3560 switch and Cisco 2911 router. This serves as the network backbone and connects all floor switches through high-speed fiber links. The distribution of access layer includes three Cisco Catalyst 2960 switches placed in a departmental IDF rooms, connect PCs, printers, and wireless access point using Category 6 UTP cabling. The wireless layer use WRT300N access points strategically placed in reception, central meeting and presentation areas to provide full Wi-Fi coverage for both staff and guests. The horizontal cabling layout connects end devices within each department to the local access switch, while the vertical cabling layout connects each IDF switch to the MDF core via OM33 or M3 fiber optic backbone links. This physical structure ensures efficient connectivity, easy maintenance, and scalability for future expansion. So this is the floor plan, and the green eclipse symbolize the Wi-Fi coverage of all end devices. So as we can see here, the Wi-Fi coverage covers the whole floor. So this is the cabling plan, and we can see there has totally four racks, and three racks will be connected to a single racks in the MDF room, which will hosting the Cisco 3560 switch and also the Cisco 2911 router. Next. So proposed logical design include a logical topology IP addressing scheme. So this is IP addressing scheme. So we have 7 VLANs. So we have 7 VLANs. So for VLAN 5, the department is management. The subnet is 10.0.0.0 and the gateway is 10.0.0.1. The second is VLAN 10, which is finance. The IP address is 192.168.10.0 and the gateway is 192.168.10.1. For VLAN 20, it's IT and staff Wi-Fi. The IP address is 192.168.20.0 and the gateway is 192.168.20.1. For VLAN 30 is R&D. The subnet is 192.168.30.0 and for the gateway is 192.168.30.1. Moving on to the next one is VLAN 40, the presentation VLAN. The IP address is 192.168.40.0 and the gateway is 192.168.40.1. And then moving on to the next one is VLAN 50 for shared printed. The subnet is 192.168.50.0 and the gateway is 192.168.50.1. And the lastly is VLAN 99, which is the guest Wi-Fi. The subnet is 192.168.99.0 and the gateway is 192.168.99.1. Basic device configuration. So for the router, the Cisco 2911, we configured with NET and DHCP to provide internet access and dynamic IP allocation. For core switches, Cisco 3560, we have host VLAN interfaces for inter-VLAN routing and connect all access switches via trunk ports. And access switch, Cisco 2960 assign VLANs to each department and trunk list to the core. And devices receive IPs from DHCP or are statically assigned based on VLAN. So the VLAN segmentation configuration, so we can see this is the VLAN configuration we have done. VLAN 10 named finance, VLAN 20 named staff Wi-Fi, VLAN 30 named R&D, VLAN 40 named presentation, VLAN 50 named printer, and VLAN 99 named guest Wi-Fi. So inter-VLAN routing configuration, we have interface VLAN 0, the IP address as I said before is 192.168.10.1, inter-VLAN 20, 30, 40, 50, and 99. So the wireless SSID design and configuration. So for SSID, first SSID is staff Wi-Fi. The VLAN is 20 and the purpose is to internal network and internet. So the access point is at reception, APv4, access point number 4. While the second is guest Wi-Fi. VLAN 99, internet access only at central area, access point 2. Have implement plan outline how the network will be deployed. So this is the Gantt chart we have done. So for phase 1, planning and design, the task description is review requirements and the duration is week 1 for week 1. So the total duration will be 1 week. For phase 2, physical setup, install cabling, racks and switches. The phase 3 will be configuration, configure VLANs and IP addressing. Phase 4 is testing and verification, test connectivity and VLAN isolation. And lastly, for the week 5 will be documentation, which is record and configurations. Required resources, technician, hardware, and software. So for the category is personnel, 1 network engineer, 2 technician, and 1 IT support staff. Hardware is 2911 router, 13650 core switches, 2960 switches, and 4 access point, which is WRT 300N, and also Cat6 and fiber cables, and also patch panels. For software or tools is the Cisco Packet Tracer Simulation, configuration backup tool, and network monitoring software. Maintenance plan, perform monthly backups of router and switch configuration, conduct quarterly network health checks for cabling, link status, and bandwidth usage, firmware updates on switches, router, and access point every 6 months, maintain a troubleshooting log for issue tracking and resolution, provide ongoing user support and update documentation as changes occur. So lastly is the bill of material. So this is our bill of materials. As we can see, the 2911 router has the quantity is 1. So each unit costs 3,500. So the total cost will be 3,500. So second is 3560 switch. The quantity is 1. So the total cost will be 6,000. So the 2960 switch, we has 3. So each will be costing us 2,500. And so totally it will cost us 7,500. WRT 300N wireless access point, we have 4. So for each unit is cost 350 and also the total will be 1,400. So for category 6, UTP cable box will be 4 and the total will be 1,800. For M3 multi-mode fiber cable, the quantity is 2 and the total cost is 1,200. The patch panel, 24 ports, we have the quantity of 4. Each will cost us 250, so the total will be 1,000. So network rack, we have 4 network racks. Each will be costing us 1,500. And the total will be RM 6,000 ringgit. Printers, so we have only 1 printer because it's a shared connection. So the total cost will be 600. lastly, PCs and workstation. So for the PC and workstation, we have 17 PCs for all department. Each PC will be costing 2,000 ringgit. So the total cost will be 34,000 ringgit. So the total estimated cost will be 63,000 ringgit. So that's all from us. Thank you, Umi.
Thank you,
Thank you,
Ni.
Umi.
Thank you.